We're going to finish up parabolas today. So here we go. 8. That's an 8, sort of. 8.1b. Okay, parabolas. Now, we're going to do 2 parts today. We are going to, we're going to graph them correctly, okay, with points and everything. And then we're going to have them in, like, standard form of polynomial and try and get them into vertex form or standard form, whatever they want to call it. All right, so here we go. Graphs. Now, I don't mind how you're going to graph this, okay? I don't know if I'm going to let you have your calculator for this one. I'll have to look. But, well, actually, there is a graphing calculator part, so I have to. So there's 2 types. We're going to do, number 1, we're going to graph by hand, okay? And it says that in the homework, in the book, it'll say graph these by hand. And then I'm going to show you how to graph them on your calculator, too. All right, so graphing by hand, here we go. Number 1. Suppose that you have y equals negative 1/6 x squared. Negative 1/6 x squared. Now, you know that this parabola is going to open down. You know that, okay? And let's go ahead and let's just graph it. But I need 3 points. I need 3 solid points on this thing, okay? So I know that the vertex is 0, 0. And I'm not picky about how you graph. If you want to make an XY chart, you're graphing this by hand, I don't mind that, okay? If you want to find the focal width and the focus and do that, I think that would be kind of a waste of time on this one. So what I would maybe do is you could just plug in a number that you think is going to work great. So 0, 0 we got. What would be another number that would work pretty good?
1.
1? You want to graph negative 1/6?
Oh, wait, no.
6.
6. All right, let's graph 6. So we square 6. 36, negative 1/6 times 36. And you get what? What over here? Negative 6. Okay, that's a good point. So we'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 6. So there you go. And we do know that there's an axis of symmetry, so we know that there's also a point over here on the other side reflected. All I need, if you're graphing by hand, is 3 points. That's it. Okay? So there you go. There you go. Yay.
Are you going to get mad at us if our parabolas aren't, like, nice?
No. No. I'll give you a grid, and then you can graph it, like, on a quiz, on the quiz, for sure. Okay, let's do another one. Number 2. Another one, yeah. Number 2.
I said that in public.
No,
Yeah,
don't.
because of you.
I know, I'm sorry. All right, so let's do this one. Say it's y squared equals 4x. Okay. This one, what you can do is you can find the parts if you want to. You can find the vertex, and you can find the focus, and that would be a nice way to graph this one. So they're kind of different, depends on the problem. So you know the vertex for this one is still 0, 0. You can tell just by looking at it. There's no h or k. Hk is 0. And then the focus would be what? Well, 4p equals 4. Yeah, so p would be 1. So the focus would be 0, 1, because this parabola, no, that's wrong. Does anyone know that's wrong? Yes? Okay, good.
It's why.
Yes, the focus would be 1, 0. Good, I'm glad I caught myself. And so that would be the focus. Now, we're just so used to doing this. Good, yay, okay. We're not going to do that, though. We're actually going to get some points, some actual points here. Now, if you have the focus, what you can do is you can graph it using the focal width. What's the focal width?
4.
4. Okay, so from the focus, if we go a distance of 2 up and a distance of 2 down, that'll make a focal width of 4. And then you have your points. Now, let's suppose you hate all of that. And I understand, that's okay. What you can do instead, like that's one option. What you can do is you can solve for x by doing x equals 1/4 y squared. And then you can make a chart. Now, when you're graphing something that's not a function, you don't want to pick x values. You want to pick y values and plug them in, okay? So it's the same thing. So if I pick 0 for y, I get 0 for x. If I pick 2 would be a really good point. 2 squared is 4. That would give me 1. So that's the point 1, 2. That's this point right here goes with that, okay? So that's the other way you can do it. You can make an old school chart and graph it that
What
way.
would you recommend for timelines like this?
Whew. When it's nice numbers like 4, 8, 16, I say do the focus. And usually I ask you to find those things anyways. So yeah, so let's do like something like number 3. And this one would be a good one to do that way also, because I'm going to ask you to find all this stuff, okay? All right, so let's say that we have 4 times y minus 3 equals x plus 1 squared. And for this would be a pretty decent sized problem. Now your book's just going to say graph it, okay? But I would say to find the vertex, the focus, maybe even the directrix line, and graph it, okay? And all those things that I make you find are going to help you graph it anyways. Now, this right here, this form that they put it in, is close to the form we're used to. The form that I gave you yesterday looks like this. X plus 1 squared equals 4y minus 3. It's the same thing, okay, just rearranged. So yesterday I gave you x minus h squared equals 4p. Here, do you want to write that down? Maybe that'd be good. X minus h squared equals 4p y minus k. So that's the formula that you need to know for parabolas that open up and down. All right, is this too warm in here? Or is it? It's all the way down, isn't it? Yeah. Okay. All right, so you got it. It was -1, 3. Perfect. Okay, so we'll plot that. -1, 1, 2, 3. All right, now let's find the focus. So this number right here is equal to 4p. And remember, p is the distance from the vertex to the focus. So 4 equals 4p, so p equals 1. All right, so then you have to say, well, which way do I go 1? You can go 1 up, to the right, to the left, down. So this would go up 1, perfect. Up 1. So there you go, there's your focus. Yeah?
Why do we know this?
Okay, we know this because x is squared. Okay, so that means it's going to be up or down, and 4p is positive. Yeah, so 2 things. Okay, so what point is that? -1, 4. Okay, the directrix line is going to be a horizontal line the other way. So that would be this line here. Y equals 2, I heard someone say it, good. Okay, and then, what's that?
How'd you find that?
Oh, it's 1 the other way. They're the same distance from the vertex. And then since this right here is 1, your focal width is 4. Okay, focal width is 4. So you're going to count 2 in each direction again. So 1, 2, and then 1, 2. There you go. And that would be the graph of it. Okay? So from here to here is the focal width, which is the whole thing is 4, so it's got to be 2 and 2. It's a really nice way to graph. If you don't like that, like I said, you can always make a T-chart, but you know, that's kind of ick with this one, especially since I ask you to find these things. Okay? So, yeah.
So the focal width is the directrix line times 2?
Oh, no, the directrix line? No, that's a distance of 1 also.
Okay, so then where does the focal width?
Okay, so the focal width is 4p.
Oh,
So the absolute value of 4p is the focal width.
So it should be on
so it was like one of the notes things that was.
Yeah, yesterday. So 4 is the focal width. And so this would be 2, and that would be 2. Okay. It's always like if this is p right here, the focal width is 2p and 2p, which makes 4p. Twice as far. Okay, you feel pretty good about graphing? All right, let's do number 2 on graphing. Number 2 on graphing is using your calculator. You're like, yay, that sounds easy. It's kind of not, though. Graphing these by hand is sometimes better than graphing on your calculator. All right, so graphing on your calculator, let's do both kind, okay? We'll do the easy one first and then the hard one second. So what number are we on? 4? I think so. Yeah, go ahead and get your calculator out. So we're going to graph on our calculator x plus 4 squared equals 12 times y plus 2. All right. In order to graph this on your calculator, we're going to go back to function mode. Okay, we've been in polar and parametric mode. So change your calculator back to function mode. So we're back to y equals. So we need y equals, okay? So we need to solve for y here first. So what you're going to do is you're going to divide by 12. And I'm going to rewrite this a little bit. I'm going to go y plus 2 equals 1/12 x plus 4 squared. And then subtract 2 to the other side. Okay? And this looks like the old stuff that we used to do. That was vertex form for a parabola. And then you just simply go to your calculator and you go 1/12, bless you, parentheses, x plus 4 squared minus 2. I'm going to hit zoom 6 and see if that works. Yeah, it's a pretty wide parabola. You can find some actual points on here. You can either hit trace. Ooh, if you hit trace, you might still be in polar coordinates. Okay, do you know how to get back to regular coordinates? You go to format, second zoom, and you might want to change it back to rectangular coordinates, okay? Can you see all that? Yeah? No? Second zoom, format, change back to rectangular coordinates. Or you can even go to the table, but make sure your table's in the right place too. All right, and then you just sketch a graph. You sketch a nice graph. You know what the vertex is. It's -4, positive -2. Okay? And then you can even like hit trace and plug in x is 0. At 0, you're right there at -2/3. That's pretty gross. You might want to try and get like a nicer point. There's a good point. X equals 2, y equals 1. So 2, 1. And then you're going to be way over here on the other side. Okay? And there it is. All right, so your calculator can handle it, no problem at all. Now, when we changed back to this mode, this was function mode. Our sideways parabolas functions.
No.
No. All right, so the next one is going to be a little trickier to do. So what you're going to do is you're going to have y plus 2 squared equals -16 x plus 3. All right, I can tell what the vertex is. The vertex is going to be -3, -2, but they asked me to graph this on my calculator. You can graph it by hand if you don't want to do it on your calculator. You don't have to do it on your calculator, but a lot of you guys like to. All right, so we have to solve for y. So what we're going to do to solve for y is we need to take the plus and minus square root. So you get y plus 2 equals plus or minus square root of -16 x plus 3. It's okay that there's a -16 in there, no problem, bless you. And then subtract 2 to the other side. So plus or minus square root -16 x plus 3 minus 2. And when you graph this, you actually have to graph two equations. You have to graph a y1 and a y2, okay? Because this is not a function, you have to graph the two of them. So then you go square root -16 x plus 3 and then minus 2. And then we'll graph negative. Now don't graph negative y1 because that'll make the -2 negative also. We don't want that. We just want the radical negative. So square root of -16 x plus 3 and then minus 2. There's the first one and there's the second one. What happened? It didn't connect? Did yours connect? You didn't do it? You and your fancy calculators? Okay, the reason why it's not connecting is because your calculator can't finish this because it's so steep. Like they can't draw vertical lines and it almost goes vertical. So that's the problem it's having. But you should be able to know what it looks like. So this goes to -3 negative 2 is our vertex, okay? And you can hit trace. See, even at like, it won't even show. So like if you hit negative 3, it does show negative 2 is a point on the graph. That's interesting. And then, you know, pick something else. Pick like, ooh, no, negative 6 or something until you get like a nicer point. Ooh, negative 7, positive 6. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There you go. And then there's also going to be another one down here. And that would be your sideways parabola. Okay? So that's graphing by calculator and by hand. Hopefully you can handle all those. All right, part B. Yes, I know. It's only been 15 minutes, though. Feels like a lot today. Okay, part B is now we are going to get our parabolas into what the book calls standard form. Okay, you might call this vertex form. The book likes to call it standard form. So here's standard form. We learned this yesterday. We wrote this down today, but it's x minus h squared equals 4p y minus k. Okay, that's for parabolas opening up and down. And then we also have y minus k squared equals 4p x minus h. All right, that's our goal, to get our parabola to look like one of those, depending on which one it is, okay? It's not going to look like that to start with. It's going to look like a big jumbled mess. So here we go. What number are we on? 6. Are you ready? No? Oh, wait a minute. Yes. Yeah. All right. Here we go. Number 6. Okay, it says, this is the way the book says it. Prove that, and I know that's a scary word for some of you. Prove that y squared minus 6x plus 2y plus 13 equals 0 is a parabola. Prove that y squared minus 6x plus 2y plus 13 equals 0 is a parabola. And then we're going to find the vertex, focus, and directrix line. Oh, they also want the focal width and a graph. Wow, that's a lot. Okay, are you ready? Here we go. Well, you can tell this is a parabola. Most of you can, because only one of the y or x is being squared. Okay. We learned that last year. We're going to talk about that later on in the chapter when we learn the other conic sections. All right, so what we're going to do is we're going to take this thing and we're going to complete the square, because we need it to be in standard form. Okay? So this is what I want you to do. I want you to leave all the y's on one side. Okay? And take the x's and the constant and move it over. So I'm going to add 6x over and subtract 13. You okay with that step? Because look at standard form. Standard form has all the y's on one side, all the x's on one side. Okay? And now what we're going to do is we're going to complete the square. I know, it's very exciting. Now, do you remember how to complete the square? You're going to take half of b, half of the middle term, and square it. And you're going to add that number to both sides. It's been a while since we've completed the square. So here we go. Y squared plus 2y. Take half of 2, which is 1, and square it, and add that number to both sides of your equation. Because remember, whatever you do onto one side of the equation, do onto the other. Golden rule of algebra. Okay? Everyone okay with that step? Now, what you've done is you have made yourself a perfect square trinomial. So that will factor as a binomial squared. Okay? So it's going to factor as y, and it's always going to be half of the middle term plus 1. All right? And if you have trouble with that, you can always do star method. What times what's 1 adds up to 2? 1 and 1. So that's why it's y plus 1, y plus 1. So y plus 1 squared. All right, over here we get 6x minus 12. Okay? And finally, there's just one last little thing. we need to factor out a 6 on this side. So we get y plus 1 squared equals 6x minus 2. There it is. Okay? That is our standard form, or yeah, they call it standard form. I call it vertex form. Standard form polynomial for a parabola. And let's find all the pieces. The vertex. What's the vertex?
2 negative.
Perfect. Yep. 2, negative 1. Okay? And the focus is not going to be all that nice here. We can draw a sketch. Now with these, if I don't say like accurately graphed or you can just draw a sketch of it. A sketch is to draw the vertex and then which way it goes. Okay? So we'll go 2, negative 1. This parabola is opening which way? We've got a 25% chance of getting this right.
Sideways.
Sideways. I know. So the y is squared. So it's open and 4p is positive, so it's opening to the right. So there's just a sketch of it. The focus is going to be down a ways, a distance of p. P is not going to be nice. Okay? So here we go. 4p equals 6. So the focal width is 6, which means you would go 3 in each direction here and here. That would be fine. But p is, you can use, yeah, do you like decimals?
Yeah.
1.5. Perfect. So then that means that our focus is going to be 1.5 to the right. So that would be at where? 3.5. Good. 3.5, negative 1. Okay? Draw a picture. It helps a lot. Because if you look at this, you're like, okay, if I have to go 1.5 that way, then that's affecting the x and not the y. So 3.5, negative 1. And then what would be our directrix line?
X equals 0.5.
Yes, x equals 0.5. Perfect. Aren't these easier this year, you guys? Yeah.
How did you get 3.5?
Oh, okay. So if my vertex starts at 2, negative 1 is my vertex, and I need to move 1.5 to the right, then I just add 1.5 to the x, not the y. The y is not changing. So I'm going right and left. Okay? All right, let's do one more. If you feel like you're pretty confident in this, you can stop there, but I'm going to do one more. Maybe you need one more. I'm going to do parabola that goes up and down now. Okay? So here we go. Oh, no, you need this one. Sorry. Oh, you're just about to close up shop, weren't you? You really do. You need this one because there's going to be a number out front. 3x squared minus 12x minus 12y plus 20 equals 0. Okay, this one's going to be a little harder because of that number in front of the x squared right there. Okay, so do the same thing that we did. Whatever's squared, you leave those guys where they're at on this side. So 3x squared and leave negative 12x. And then on the other side, you're going to bring everybody else over. So add 12y, subtract 20. All right, in order to make this polynomial on the left a perfect square trinomial, that 3 is getting in our way. So what we're going to do is we're going to factor out the 3 of those two terms. So you have x squared minus 4x, and then leave a blank because we're going to have to complete that square on the inside. And over here, nothing changes. 12y minus 20. Do you remember doing this when we completed the square? It's a little tougher because you have to factor out that number.
What happens if you factor out like a full 3x? Like, would it not work? Or?
No, it won't. Yeah, because you need to have that as x squared so you can make a perfect square trinomial. All right, so now we're going to take half of b and square it. Okay? And when we take half of b, we get negative 2. Squared is 4. But who can tell me what we're going to add to that side? Yes. You love complete the square. Okay, do you see what I added to this side of my equation? I added 12. 3 times 4. So you have to go over here to this side and add 12. I love that part. I love it when you see it. All right, then we get 3.
Math goosebumps.
Right? Math goosebumps, yes. And this factors as x minus 2 squared. And this is equal to 12y And then this is what? Minus 8. Ew, why did I do that? That's really bad, huh?
What did you do with the 3?
That 3 there is bothering us too, huh? Yeah, you're gonna have to factor out a 12 and then divide by 3.
What?
What?
That's gonna be so ugly.
I know, that's
How do you
really
factor out
strange.
12?
We did all this right? Because normally I make them turn out nicely. We added 12, we got negative 8. Multiplied by 3.
Did you write
Ew.
the problem down right the first time?
Let me see.
You factor out an 8, right?
Yeah, then you can factor out a 12. Okay, so one little mistake. This should have been 24. Change that to 24. Change that to 24. Okay, so then when we do this, we get 12y minus 12. Better, okay?
That should have been 20. Oh.
Yeah. No, we're good. It's okay. It only just did that. It had nothing to do with our squaring and all that stuff. All right, so then you get 3x minus 2 squared equals, factor out the 12, and we're left with y minus 1. And then finally divide by 3. There we go. X minus 2 squared equals 4 times y minus 1. And then you'd have to find all the stuff, which we're going to go ahead and stop there.